Shall we call this is h? Find the value of h is telling. So this is that h. So how the meniscus will be? This is the meniscus. And here it is flat. I'll show some other color, meniscus. Okay, let's get into. So he's asking that h. So what shall I do now here? So I'll proceed in the similar way. The points, I'm interested in these particular points. There's a point 1. This is 2. This is 3. So this is 4. This is 5. Okay, there's a liquid of density rho. What should be the pressure? And there's a pressure at 3, 5 should be equal to P naught. We are discussing the first part of the problem. Pressure at 3, 5 should be P naught. Angle of contact 0. If angle of contact 0, then what should be the radius of the meniscus? Should be equal to capital R. Am I right? If angle of contact 0. Radius of left to be smaller. Okay, fine. Capital R is what I'm writing. It will be flat. Meniscus will be flat here. So here you write it. Flat meniscus. Okay, let's write here now. P3 equal to P5 equal to P naught. Let's write another equation. P3 equal to P2 plus 2 times of surface tension into radius. P3 equal to P naught. And P2 plus rho GH minus P1 equal to 0. P2 is how much? P naught minus 2TR plus rho GH minus P1 equal to 0. Since pressure at phi is equal to, anybody, why I should equate pressure? Because meniscus is flat, no? Pressure at 4 and 5 should be equal. And we know that because of horizontal line, P1 must be equal to P4. Look at horizontal line. So what is P1? P1 should be equal to P naught minus 2TR rho GH. P4 equal to how much? P naught. So what is H equal to? 2T by rho GR. There's the first part of the problem. Let's come find the maximum value of H for which the water will not flow out of the left tube. What actually happens here now? Now initially you see this was a curved, no? As the water level starts increasing, what will happen to the curvature of this? So it was having curvature. The curvature, what happened of this start decreasing, becomes flat, then it will become concave, and finally what happened at one particular point, it will emerge out. So the curvature, I'm going to show it at left tube. What will happen to the curvature? First, it was equal to R. Next, it will be flat. Then finally, this will be the condition. So this is what meniscus at left tube. Okay, this is something very important. As H greater than 0, meniscus at tube, at left tube, This is for H equal to 0. This is for H max. This is for H, what we have calculated. As I further increase, what will happen to meniscus? Now it will become convex towards A. Earlier it was concave towards A. No, now it will become convex towards A. This one. No, it will be like this. So for beyond this, what it cannot retain. So that we have to go into discuss now. So I'll take the help of this diagram. I think, okay, this is not needed. We'll start the discussion here. I'm going to, I'll call this as H max, the same thing. So here, how the meniscus will be? The meniscus will be agree this. So this will be, so now 4, you bring this is 5. Let's get into the same analog here now. So what is a pressure rate 3.5 in this case? Pressure rate 3.5. No, not it. Pressure rate 3.5 should be equal to P naught. Pressure rate 4 should be equal to P5 plus 2T. What shall I write here? R only, because angle of contact is 0 is still in. So what is P5? P5 equal to P naught plus 2T by R. Let's get into this one. P3 equal to P2 plus 2T by capital R. P3 is how much? P naught. P3, P naught, P2. Further, P2 plus rho GH minus P1 equal to 0. P2 is how much? P naught minus 2T by capital R, rho GH max. Rho GH max minus P1 equal to 0. We know P1 equal to P4 because they lie on horizontal line. I need a spacer. Shall we put a condition now? P1 equal to P4 horizontal line. Okay, let's substitute P1 equal to how much? P naught plus rho G H max. P4 equal to P naught plus 2T by R. Anybody value H max should be P naught get cancelled. So 2T rho G 1 by capital R plus small r. This will be our answer. Okay, now this is very important, the meniscus. Here water, and it will be air.